While the last people are just getting seated, I'm just going to run through the standard housekeeping that we do every session. External toilets are located in the lift bay, down the corridor to your left, past the lifts and to the left again. Emergency exits are located in the hallway by the lift foyer. In the event of an emergency, you will be guided by property managers via intercom. In this instance, please evacuate using the fire exit stairs accessible by the hallways by the lift foyer. Do not use the lifts. Once on the ground floor, you will be advised and directed to the evacuation meeting point by security. Please switch your phones off or to silent mode to avoid any disruption. As is our custom, Engineers Australia would like to acknowledge the traditional custodians of this land and pay our respects to the elders, both past and present, of the Kulin Nation, and extend that respect to other Indigenous Australians and Torres Strait Islanders present. Okay, just another little bit of housekeeping. Just recently we've had the Australian Systems Engineering Workshop, and we have Roger McGowan here to just give us a little update on a bit of success we've had with a in-draft document that's going to be guidelines for applying systems engineering, or for addressing systems engineering. Okay, I'll just...
Thanks, Emma. Yeah, at the last October we had the Australian Systems Engineering Workshop, and we ran a transportation workshop stream at which quite a number of delegates put forward what they had identified as pain points that were adversely impacting being able to succeed in doing their aspects of projects, particularly transport ones, but we also had a few other delegates from other parts of civil infrastructure. As a result of that, we then condensed the something like 40 pain points down to 8 categories, and because of the limitations that we had within the workshop, we addressed 3 of those in detail, looking at all the different aspects and perspectives of those pain points, and as a result came up with sets of requirements that would hopefully, if implemented, alleviate those particular pain points. And as a consequence, combining those requirements, we've come up with a document that has basically principles and guidelines, or principles that should be adopted for infrastructure projects generally, transport ones in particular, and guidelines on how they can actually be implemented and recommendations for them. I'm letting you know this, it's available on the CISA website to download. I think some of you probably were at the ASEW. Certainly you might want to look at attending the next one, which is 27th, 28th of October here in Melbourne, and it's going to be here in this EA facility, and where we'll be investigating more of those pain points and supplementing this document. So letting you know that. Thank you very much.
And now I'll call upon John Nasser, co-chair of the Victorian Systems Engineering Society of Australia Transport Working Group.
Hello everyone, my job is to introduce the speaker, so I'm not going to keep you very long. So today we came to hear Marcus Chadwick. Marc is the Manager, System Architecture, Integration and Assurance at Rail Projects Victoria. Marcus has over 35 years experience in the rail industry, covering private sector work in the development and application of rail signalling and control safety products, and Victorian public sector work in the specification and delivery of signalling and major rail infrastructure projects. In his current role, he leads the systems engineering and assurance function for RPV and its portfolio of projects. Marc today is talking to us about a very applications-based topic, so I think it'll be very interesting and lots of lessons to learn. So everybody please welcome Marcus Chadwick.
Okay, good evening. Thanks for that introduction, John. And it's great to see a good attendance, and hopefully I've attracted people from the rail industry, but also people who aren't necessarily practicing in the signalling, in the systems engineering domain, and that's one of the challenges we've got to improve the capability and the value, identifying risk through our project delivery. So presentation tonight, I'm going to take the opportunity just to reflect on my work experience in rail, which has been well over 30 years, what I've been involved with, the lessons I've learnt along there in terms of system engineering and its application, through to where we are, where we got to recently at the end of one of our major projects, and now what are we moving forward with within RPV, which is Rail Projects Victoria. So in addition to that, also introduce the investment life cycle. So within the government, there is actually an investment life cycle that all the projects actually are tied into, have to go through various approvals to actually get awarded and get put out into the market, and ultimately we need to track them through to delivery and realisation. Some of the techniques that we've also introduced in terms of a consistent approach to our assurance activities, and just some final comments. So Rail Projects Victoria, who are we? We're a projects office within the Department of Transport. We're one of 5 project officers reporting through to the MTIA as an overall infrastructure governance group of our project delivery. So we've got level crossings, rail authority, level crossings, removal projects, east-west, major road projects, and Westgate Tunnel, plus Rail Projects Victoria. And within RPV, we've got 5 major portfolio streams of projects, being the Metro Tunnel Project, Regional Rail Revival, the Melbourne Airport Rail Link, Suburban Rail Link, and Western Rail Plan. So I'll briefly just outline some of that work. So RPV's portfolio is covering the whole state of Victoria. So we've got projects happening both remotely in the regional areas, plus in the city. So starting with the Metro Tunnel Project, which creates from Sunbury all the way through into the city, creating a new underground tunnel system through the heart of the city, and ultimately delivering services down to Pakenham and to Cranbourne. The Regional Rail Revival, that's got pockets all around the country, from Geelong, Ballarat, Warrnambool, up there in Bendigo, Echuca, Swan Hill, all the way through to the northeast, and down the southeast we've got the Traralgon Bairnsdale area. So a large activity of projects happening in the regional area. The Airport Rail Link, so that's providing a connection, a rail connection through to Melbourne Airport, and it's got a identified alignment from the airport through to Sunshine. We've got the Western Rail Plan, which is increasing, is providing electrification out to Melton and to Wyndham Vale, as well as faster train operations from on the Ballarat line and the Geelong line. And also sorry, I'm having trouble reading it. There's a new line effectively needs to be delivered from around the Sunshine area into the heart of the city. And the final program of work under RPV is the Suburban Rail Link, and that's providing a connection between the Melbourne Rail, Melbourne Airport, all the way through the east, through the east, and down to the southeast. So that's a long-term project. So on that, it's very much in the feasibility planning stage. The airport rail, there is a commitment there to develop that, get it through to a business case. Regional rail revival, many of those projects are in contract. A number of them are still in development and going out to the market. And Melbourne Tunnel project is awarded, and we've got 3 package contractors delivering the detail of those activities. So my experience in rail goes back through to 1984. So I just wanted to outline where I've been working, what I may have picked up in the areas of rail. It's application of systems engineering within whatever context that was, through to where we are today, where we've got a large portfolio of projects and where systems engineering and the assurance actually will play a higher well, it's addressing the risk. We've got such a large, complex suite of projects. Our whole assurance and governance just needs to lift to be able to manage us through to successful delivery. So just the maturity timeline all the way through from the 80s to 2015. So I originally started with Westinghouse, worked in the train control system development, and that was, I came in as an electrical engineer, and the systems thinking associated with a train control system was all quite straightforward. We're introducing a centralised train control system. It had to communicate to remote locations. So exactly how would that architecture fit together? So you've got some centralised computer equipment, you've got remote equipment, you've got a SCADA system that needs to interconnect it all, and a communication system. So a lot of the architectural detail was quite obvious, that you just systematically work your way through identifying, well, where are we operating? What are the solutions that we can roll through? What are the available products we've got? Do we need to do any development to create those products? What sort of tailoring do we need to do with existing products? What software would we need to develop? So there was a natural adoption of a system engineering approach to the train control system environment. A lot of processor-based equipment, so that's black box, it's hidden. What's in there need to be assurance processes to work your way through that and be able to demonstrate that whatever requirements being implemented have been successfully delivered. Now, just contrast that with the signalling. Very much the signalling is localised. All your safety of the railway is embedded in the local interlockings. So there's a whole pedigree of history in railway and the safe operation of railways, and the signalling actually is where that resides as a fundamental. And the technology that was available during the 80s was all either mechanical or it was electromechanical and relays. And you could actually see the equipment. You could see the equipment moving. So you could always detect whether a relay was energised up or whether it was de-energised down. So it was quite primitive type technology. Although the detail was down in the interlocking level, that had a whole lot of principles behind it. So there wasn't much novelty as such as to what happens in the signalling side, compared to the train control, where we're actually trying to achieve a corridor-wide outcome, and signalling is one of the components and ultimately the safety barrier for the whole operation network. But the train control sort of bridged that together. During the early 90s, I moved into the product development side, and that's where we started to explore more advanced technology systems. and that was ATP, automatic train protection, which was a first for Australia, and we developed a local capability in safety critical software, high integrity hardware products, and that we were a one-off in Australia as an organisation. Developed a great capability there. A number of people who are now run into in the rail industry, now on the project delivery side or in the bigger project delivery space. So it's been a good foundation of a lot of the system engineering type principles. So in terms of system engineering, so systems thinking, well, in an ATP where we're trying to put train protection on board the train, integrate that with the operation of the infrastructure. You need to look at that train, look at the track, look at the signalling. You could actually get quite a clear context, a boundary around what that system was endeavouring to achieve. So identifying a boundary is a critical factor in a systems engineering application, and then from that you can then start to break it down into the subsystems that make up that system through to its lower level, splitting it out into hardware or software components, and then look at how you actually rebuild that up. So integrate all that module level up through the life cycle into an integrated system. Part of that development was also to do with interlockings. So we moved into electronic interlockings. So the Westray suite of products out of Westinghouse, we were developing portions of that technology suite. And we were applying a lot of the industry standards. There was an RIA 23, which is effectively how you develop embedded software products. Ultimately, was replaced by the Senelec standards. A lot of the formal processes were required. So, what sort of techniques did you actually need to have in your system to as defences against systematic type errors? Formal sort of aspects, how you manage your requirements, how you set your configurations, and ultimately with a safety product, there need to be safety assurance behind it, and using an independent safety assessor as part of the strategy and demonstration that you're meeting the safety requirements. So I guess I'm highlighting there that train control people who've been working in that space, fairly natural in terms of system engineering sort of application. People involved in product development or clear products, applying a systematic process to work your way through whatever you're trying to solve, fairly straightforward. But what I've found, we moved into larger rail project delivery, and that was quite a pivotal moment that I discovered that a lot of what I'd grown up with in terms of system engineering, a systematic approach, capturing requirements, just wasn't naturally done by the major construction organisations. All right, so the Regional Fast Rail project in 2003 through to 2006, I actually did get to observe systems engineering in practice, but it was a little bit indirect. The specifications were written very much around performance. We needed to have a train get from Ballarat to the city in a certain time, similarly for Bendigo and the other two corridors. So exactly how the contractor solved that was largely up to them. But where those solutions were coming from, track speeds was a key one. Exactly what your signalling capacity, any constraints introduced by the signalling, and also when the line speed was actually upgraded in Victoria to 160 km/h operation, there needed to be a new layer of safety introduced to the train. So there was a train enforcement system. So indirectly resulted in the track component and the signalling component needing to work together to solve the infrastructure solution to support 160 km/h operation, and then for that system, the signal and the train systems to integrate as well to provide the relevant safety performance for a train operating at that speed. And to prove all that, we had to run through performance testing, so actually practically running the trains out there at speed, deliberately going past a signal at stop and seeing intervention of the safety system on the train. And also that project needed an assurance case to demonstrate that it's okay to step up to the higher speed operation. So a safety case is quite a new term, I'd say, to the rail projects. It is now something that we are using as our standard vocabulary, either the safety case or the assurance case, picking up the whole assurance activity for a project. But traditionally, a lot of the integration and acceptance into the rail network has relied on the accredited rail operator's environment, and just satisfying that got it into service. So it wasn't necessarily a collation of a whole lot of evidence. It was sort of a bespoke approach just to get the assurance and demonstration of safety across the line with that rail operator. So yeah, at the bottom there, realisation that systems thinking was not necessarily natural to the projects. Definitely those working in the train control, as I said, but the civil builders, no, they didn't understand how you would naturally start with your requirements and decompose it down. So through the 2000s, the investment in rail continued. A lot of projects were now starting to roll out. And again, just to sort of harp on highlighting a systematic approach to how rail needs to be assessed and prosecuted through the life cycle. I established a signalling life cycle, which served a number of purposes, but part of it was consolidating. We all start with the operations and the business need. That's where we all start in our projects. So we need to actually understand that, and how do we go through and decompose that down into something. And so I was able to use this just to highlight in more of a signalling application. We need operation performance requirements. So what is the capacity of the line? What type of operating moves do I need in a railway? Get that specified, then that can be then allocated into requirements, and then we can go through an architectural analysis of, well, how would we solve that in the signalling domain? And it basically splits out into two concurrent activities, one down the signalling stream and one down the train control stream. And this illustration proved to be quite informative and educational to our standard civil engineers. So as part of the growth of the rail industry, a lot of people came in from external to the rail. So a lot of people came out of the roads industry into rail, and this actually proved to be an effective way of highlighting, well, there's a systematic process here, and we've got these signalling contractors, and it all appears to be black magic, and it's all under secrecy as to how signalling works. I broke it down into something that was quite basic, that they could understand, well, how do we actually move through the life cycle, breaking it down? What sort of artefacts do we get out of these stages? And ultimately, how do we pull them back together? Which ends at the commissioning stage, where we've pulled in our train control activities, our signalling activities. the whole life cycle there, from requirements, the system design and the architecture, lower level design, through to build it, through to integrate it together, through to get it to commissioning. Then in 2009 we started the Regional Rail Link project, and that was an opportunity for me to directly contribute to how we specify our approach to system engineering into the projects. It was a little bit of a loose specification. It was more that it was a theme that we wanted the industry and the project deliverers to understand that we are talking about a system here. So the Regional Rail Link was to create an independent line separating the metro services from the regional. So it's quite clear that we could define a system there, and we could talk about the system, and identifying that we had a regional component and a metro component in aggregation. That is the Victorian Rail Network. But what's down underneath each of those, the regional and the metro areas? So where we play is in infrastructure. We're an infrastructure delivery, but there's an operations component as well in terms of how we ultimately deliver a rail service. So how do we break down the infrastructure? In this case, track and the civil components, the signalling components. Well, actually, that's train control, signalling type systems, and there are other disciplines also out there. Breaking that down into a lower level. So using this as a bit of a tool just to sort of articulate, explain the principles of a system, setting your boundaries, how it actually breaks its way down. And one of the arrangements with the delivery of the RLL was an identification of one of the packages to be the Rail Systems Alliance. So it was a natural applier of this approach, where it was operating in the train control and signalling space and solving whatever has to happen down at this level. They also brought in a capability as a systems integrator. So we used that particular contractor to actually bring together a lot of the other packages as well, who were building the track and civil infrastructure. This model also proved effective in working out the RAM. So how do we work through, allocate a reliability, availability, maintainability target? So what sort of performance did we want to get out of this project? And that was where the Rail System Alliance, they were given some high-level performance objectives at the infrastructure level, which they then decomposed down into their space, and then ran that through their life cycle, and were able to demonstrate achievement of the defined performance. So some of the system engineering concepts that we adopted during the Regional Rail Link, a life cycle, recognising that, recognising requirements capture and devolving it. So although we had civil contracts out there, actually getting them to allocate the requirements and aligning that, verifying that through the design process. So it only happened down the left-hand side of the V as a practice, but at least it gave the client confidence that the requirements were being allocated into the design. And just as a general system, thinking, start at the top. You don't think in the solution space until you've done necessary analysis to break it down. So, think in the solution space after you've done the work of analysing either the requirements or the system design, the subsystem design. Okay, so recent changes to the rail industry. So MTM, Accredited Rail Operator, ONSA and PTV have all highlighted that good practice would require standards. And so each of those three organisations around 2014 published a reference that then became a source that, as a projects organisation, we can then take forward and bring into our life cycle and cascade what's relevant down into our delivery models. So on Melbourne Tunnel project, we kicked that off start of 2015. I had a very small team at that stage, but given that we had those 3 standards in place, it was a contemporary project. What was happening around the world needed to be considered. So obviously there needed to be some direct application of system engineering techniques and processes. So that forced that we needed to document management plans associated with our system engineering and assurance activities, adopt relevant international standards, make sure we were clear on our boundary. So in the development space, a lot of our people tend to go over the boundary, dip into areas of consideration that actually aren't our concern. So it was a matter of guiding where we should be putting our attention in within our boundary, setting up the architecture of, all right, well, what's going to happen within that boundary, introducing requirements management in a formal sense and adopting a tool, introducing stage gates. So stage gate reviews was a key change, I would say. So through our standard design arrangements coming in from contractors, they would give us a preliminary design, detailed design, final design, and issued for construction type design. So there were naturally reviews happening, but stage gates was a new concept where we're going to roll that up to a certain point in the life cycle and require the owner of that activity to assure the layer above it that what they were doing was appropriate for that part in the life cycle. Also recognising that with a major project like the Melbourne Tunnel project, that integration was going to be a key part, and the market testing prior to that point had assumed the previous type approach where we'd have a number of major civil packages, but hadn't really recognised, well, how do we pull those civil packages together to form an integrated outcome? So there was an identification there that we needed to introduce integration into the delivery strategy. And underpinning all that, we would need to produce an assurance report, an assurance case that pulls together all the activities that the project has done through its development, through to delivery, through to acceptance. So some of the challenges that we encountered, the project scale. So it was a huge step up relative to anything we'd done up to that point in the rail. It was novel, so a lot of new technology and systems are out there. There's also the packaging arrangement, as I mentioned, having a number of packages, and then how do we integrate that together. The skills and experience of capability in rail from our system engineering side, we're light. From the major scale of this project, we're light. So there was a big step up across the whole engineering activity that needed to be worked out. There was still a lot of silo thinking, discipline thinking, people moving straight into the solution space without actually understanding, well, what are the requirements, and devolving them down. Also in the requirements elicitation, so stakeholders use the opportunity just to throw everything across to us as a delivery authority just to process and say, well, that's what I want. Well, we need a bit tighter control over what you want. Does it actually stack up against the benefit? So there's been learnings on how the requirements are captured, elicited, and made relevant and consistent with our approval. Standards, there weren't any relevant tunnel standards available that we could go to with the accredited rail operator. So a lot of new sort of reference information needed to be created, and a complexity of how we manage the delivery and the scope. And one of those techniques which we introduced to understand the system, how we're breaking it up amongst 3 packages, was to use a system breakdown structure. And in this arrangement, we've got three packages: the Rail Systems Alliance, who are a whole of corridor alliance. They look after the technology type systems. The tunnel environment, so creating the new underground tunnel and the parts of it, and a surface contractor, the Rail Infrastructure Alliance. So all those boxes aren't actually all contained within those alliances, or not necessarily. Some of them have dependencies as to how we've worked out our scope. One part may be responsible for that product, but actually it needs some input from one of the adjacent parties to actually be used, or we may be relying on one of the other parties to do a particular task. So we actually broke down each of the subsystem boxes into its own little life cycle, from a specify, a design, a supply, integration, test, acceptance, through to who was going to operate and maintain the asset. And so by understanding who actually is participating through the life cycle for all these systems, we're able to work out, well, what were our interfaces between all the packages. So that was, I think, quite novel to the industry, and we received very positive feedback that it was an effective tool, and it is still continued to be applied to manage the scope and the interfaces on MTP. All right, so with RPV, where are we today? So we've grown from managing one large project, being the Melbourne Tunnel project, and now managing a portfolio of projects. So as I said at the start, Airport Rail Link, Suburban Rail Link, Regional Rail. So there's a whole gambit of projects that we're now needing to manage, and therefore we've had to grow accordingly to support such a large portfolio of projects. So we've had the growth. We've currently got 350 staff operating directly with RPV, associated with the whole of life cycle, from people working in the development space through to the delivery space, through the governance of an office, through to what has been established is a systems integration group, which includes these sort of items. So it's a group operating across the whole of the portfolio. We're an RPV engineering, operations and integration group. So we're not necessarily aligned to any particular project or portfolio. We're trying to establish things across the whole portfolio. And we operate through the whole life cycle. We're supporting the management of the complexity and engineering and assurance. So complexity, I'll come across that shortly, and novelty. We're needing to develop the tools, the processes, the references, so that our people working in the development side or in the delivery side of our life cycle have got a point of reference, and it's all integrated. We provide a monitoring function to assist in the management and the development and delivery of risk, and we do recognise that although we may have a boundary set that's defined by a client set of requirements, we won't be successful unless we actually get the assets installed into the new network. So we do actually have a network integration role. And that's one of the changes for me personally, that I've applied a very much a narrow view. What is my space? Just make sure what's happening within our space is appropriate. But you may have left a hook back into whatever that asset is against what the outcome actually achieves. So I'll come to it shortly, but it's more about that validation side, that we've actually built the right thing. So one of the tools we've introduced is the life cycle. And within the government, we already had a life cycle defined, and that's with the Department of Treasury and Finance. So understanding, all right, we as a project organisation, we need to map into that. We won't be kicking off any project work unless there's already been a level of approval, some funding allocated. So there's already a life cycle identified there from concept through to proving, procure, implement and ultimately realise these projects. So it's all about an investment and lifting capability into the public transport network. So I had to actually break that down as to, within Rail Projects Victoria, where do we play through the life cycle? Where do Department of Transport play? Department of Transport are effectively our client, so I view them as the client. They own the client specification of what this project's to do. They go through the planning activities, getting those front-end approvals, and then ultimately it comes across to RPV to start the development activity. Break that down into what could be a system solution, breaking that down into what could be a contract form, what could we put out into the market. So we've got various stages and also some differentiation there between stages and phases, just to help where we tie in. We also recognise the various design stages from the concept through to a reference design. We go through a tendering design activity. We get the contractor to do their real design and ultimately produce an as-built outcome. So from the RPV's engineering assurance perspective, what we're, the way we operate is we're collecting objective quality evidence through the life cycle. And what we're trying to gain the confidence of is, are we building the right thing, and will we build the right thing, and are we doing it in the right manner? So those two sort of key sort of principles. So targeting those two fundamentals actually, and doing it progressively, actually will give the confidence through to RPV, or RPV's reporting up to DOT, that the work that we're doing will actually deliver an integrated, successful, safe, compliant type outcome. Some of our principles. So what we've got, a hierarchical assurance. So when we play, when I'm talking about that, identifying where the client sits, what's the client's responsibilities, where does RPV fit in as a projects delivery office? Where do our contractors fit in? And what's their responsibilities? Where does the accredited rail operator fit in? Where does ONSA fit in? So having a quite clear, visible identification of who are the parties involved in the whole assurance flow then provides clarity as to who is responsible for what functions. Progressive assurance, that's just a common theme, that we can't wait to the end, commission it, and then find we haven't actually delivered the business needs, the whole objective of the project. So regular progressive assurance through the life cycle, ensuring that we're doing it in the right manner and we're going to achieve the right outcome. Risk-based, So one of the aspects we need to continue to touch in on is risk and novelty. So where the risk lies, we need to identify that, and that's where you need to apply the effort. So if there's a whole lot of business as usual type activities, well, that doesn't need prosecuting and great amounts of effort and assurance evidence to demonstrate it. But where there's risk, where there's novelty, that's where the value add occurs, and building up everyone's confidence. Introducing scalable and consistent approaches, making sure it's right-sized. So although we're rolling through consistent guidelines or references, there's also an assessment of significance that actually dictates, well, to what level of detail do we need to go to. So for a simple business as usual type project, there's not too much rigour applied to the assurance program because it's already covered by the ARTOs activities. But when it goes into something like Melbourne Tunnel Project, which is brand new, novel, high risk, high complexity, then we need to have a lot more definition of what that assurance program is about. Competency and independent assurance, so ensuring that we've got competent people being used in the projects. Where required, we get independent assessment against where the project's at. Again, all to generate confidence that the project's moving forward appropriately. So illustrating the various sort of layers that we're talking about, Department of Transport is at the top of our hierarchy. They'll prescribe down to us client requirements and assurance requirements down to the RPV function, and then we'll process that and ultimately deliver that through as a contract specification to a package contractor via what we term as our PS&TRs, our project scope and technical requirements. We also receive operation and maintenance requirements, assurance requirements from the ARTO, so MTM or VLINE will pass down their requirements that RPV has to process and understand and respond to. So just on the levels, who is responsible for what function? So the Department of Transport assuring that the network, that this change to the network state's going to be appropriate. So that's the future network state. We've currently got an existing network state and we're going to go through a transformation to actually change the capability of the network. So DOT needs to make that assessment and assertion. At RPV, we're responsible for delivering the project, so we need to be satisfied that what happens in our project is correct. And down at the packaged land, they're responsible for delivering against their PS&TRs. All right, so that was the requirements coming down that path. What are we doing in terms of the assurance, collating the assurance coming out of the activities? So the big sort of reporting point is the use of stage gates. So through our life cycle, identifying where we are, doing a system requirements review stage. So right at the front end, making sure you've got your requirements captured. And at a package level, they should be doing their own self-assessment that they've actually got their systems in place. They're demonstrating maturity to whatever that assurance point is in the life cycle. They then promote that up to RPV. We've established there an assurance and configuration board, which involves RPV team together with the ARTO team, so the accredited operator. And we look at what's coming up there to make sure that it's representing appropriate evidence, demonstration that they understand risk, they're reporting risk. If they're moving forward, they understand the risk. And going up from RPV, we need to go back to our client and assure them that everything that we're happening down in our project delivery or development space is consistent with their requirements. Similarly, from those ACBs, with the ARTO participating in our ACBs, they are able to pass up the evidence coming out of those ACBs straight into the ARTO's business to make sure that they, as a business, are ready to accept the change or be satisfied that the project's evolution is consistent with ultimately allowing them to take on that asset and introduce it into service. Okay, so back to the life cycle, just highlighting where those assurance points are happening. At the DOT level, there's a collection point here where we get the early requirements. So we lock in the requirements that we're going to commit, well, the client wants the project to respond to. So we've got to take that down into our delivery space, develop a concept, understand what it means, build up how we're going to approach the delivery of that. At RPV, we actually do a concept type design. So we actually typically use a technical advisor to undertake technical design work. So we roll up that information, present it to the ACB. So we've got our own sort of assurance happening down here, plus what we have to push up to the client level via that gate. Similarly, we test in against the reference design. So as we move through the design development, prior to going to contract or prior to going to the market, we build up a reference design, making sure that's appropriate, it's responding to the client requirements, which have gone through another maturity stage there. So we're all aligned, ready to go to the market. And then we go into the market and there's a tender design come in and we appraise that and go through a review stage there to confirm that, okay, if the proposal coming back from the market, okay, yes, that is aligning to our requirements. It'll align to the achievement of the client requirements and the overall business needs, and whatever adjustment needs to take place through that negotiation. When we go into the actual delivery, so we've awarded contractors, we've got our standard assurance gates from system requirements review, system definition, a preliminary design, an IFCR type point. Then we go into the construction, build it, and then we go through an integration and test, ultimately through to an SAR, system acceptance review point. And as in an RPV, in a MTP project where we've got multiple projects delivering, RPV actually needs to conduct its own collation of all that evidence that's happening down there across those three packages, consolidate that, be satisfied that it's delivering against our intended requirements, and then promoting that back up through to the DOT level. All right, so one of our themes is developing consistent approaches. So what have we got in RPV's sort of portfolio of tools and processes? We've got a project management framework, so that goes across the whole of RPV. So we're putting a whole lot of information into that environment, guidelines associated with how we go through client requirements, system requirements, PS&TR requirements, assessment of significance. So a whole lot of documentation there that we're now consolidating, putting into that PMF. One of the new aspects is the introduction of the Assurance and Configuration Board Charter. So that's our key assurance reporting mechanism that we get from our package contractors up to the RPV function. So that's now part of our whole delivery approach. Only recently has it been recognised in the contracts, but we've rolled this through to the existing contracts, and our contractors are using that as a standard approach, which is consistent with what we'd like. We've introduced requirements management and DOORS NG as our repository of requirements. So DOORS NG is a collaborative environment where we can have multiple projects, multiple contracts, multiple sources of information, keep them all separate, but actually able to cross-interrogate across. Introducing an assurance argument, so building up an assurance case using goal structuring notation as a framework of visualising what is the assurance argument and what's associated with collating the solutions to do that. And also introducing a consistent set of projects, scope and technical requirements. So down at our contractors, we want to be able to promote that, all right, here's a standard set, you've seen it before, you'll understand what our expectations are, and so get a bit more repeatability, more accuracy in terms of contractors understanding the risk. Okay, and in our DOORS environment, just a quick illustration there, where we've set it up, we've got a stakeholder level, a system level, our contract level, and our package contractors working in their space. So collecting stakeholder requirements, consolidating that through to a system, allocating them down into different specifications, and then getting the contractors to work down here, and that's all one integrated database. Security and permissions actually restrict what's available to users, but we manage that. So it's proved to be an effective integrated tool. And just on the assurance case, what are we trying to collate there as our overall argument? So we've standardised on a top goal from our projects, that we're compliant and we're ready to deliver a safe outcome that is safe for the operator to maintain and operate into service. And through sort of a visualisation, that's our top goal. So how do we have to solve that? We need to break that down. We break it down into a safety level, requirements level, governance level, and then within all those top level goals, that then gets broken down further, and then you'll get down into the solution space where you'll be, say, using design artefacts as the solution. So you're able to consolidate that all into one environment. We have nominated ACE as the tool. To date, it's been more of, the application's been more from the graphical point as opposed to using it as the repository of information. So that'll be something that will develop a greater level of understanding and application going forward. So final comments. There's obviously a level of maturity that we have achieved within our rail projects. So there has been a lot of growth that's happened, quite transformational to a lot of our users, our organisations, but there's still a number of challenges left. So making sure that we capture risks. So that's a key one. Just don't give us all the evidence and then leave it up to the approval organisation to digest, well, what's actually material risk? So what's the residual risk in here? Bring it up, consolidate that, summarise it to what are the material risks at this point in the project. Noticed a lot of the work actually is organised during the tendering phase. So we expect once the contract's awarded, all the management plans be created, put into place, then you go through your systematic process of capturing the requirements, breaking them down, allocating them out. Well, a lot of those decisions have already happened. So that's quite a reality check for me. So we need to do a bit more at our front end to make sure that the work that happens through the tender actually flows into the actual contract, and we're not getting things done ahead of time. So there's a lot of early works that type activities that are introduced, but we actually haven't done any assurance reporting that what that's going to deliver actually is aligned to any requirements. Linear life cycle, so a similar sort of theme that, yeah, we've got this standard approach of going through our requirements, our system definition, but there are a lot of things happening in parallel with that. So it's actually tying something more practical in there, that a linear life cycle in a major civil contract space doesn't necessarily happen in practice. And I'd say what we need to be conscious of, what is the risk? So we need to be testing back in against what is the risk that's being carried forward, should the contractors be doing things ahead of those ideal linear stage gate points. Experience capability, so we're all on a growth curve there. So what can the market expect? Further prescription of our requirements and our expectations. So we've done a lot more lower definition of our expectations in terms of system engineering assurance, but I'd say we've still got further definition required there to create the certainty from both the contractor side and how we organise and operate within RPV and upstream, and ensure that we put our effort into identifying real risk and novelty and not challenging business as usual type practices. So what is the real risk that we're moving forward with? That's where the effort goes in. That's where the value add comes in across everyone who's participating in our environment. So, thank you.
All right, we have about 3 minutes. I think we could fit in 2 to 3 questions. If you do have to run for a train, feel free. But if you have a question, hand up, I'll bring you the mic.
Thank you. David Clements is my name. Thank you very much for the presentation. You covered a lot and I didn't realise where we got to. My question, you mentioned the operators, for example, Metro and the tunnel, and they're operating under a long-term contract. And of course you're setting up a long-term contract in respect of the PPP contract. You didn't mention involvement with the contract operators in the government, I think PTV. I just wonder if you want to comment on how you bring those people into, I guess, their requirements in terms of contract conditions. You mentioned risk allocation, best paid, but manage the risk, etc. Do you just want to comment on that end of the, I guess, the projects?
Yeah, so PTV are responsible for managing the franchises, setting them up. So part of that sort of does get injected in through the client requirements document. PTV also actually generate the network integrity assurance plan as well on behalf of DOT. So their whole assurance sort of function that they perform actually does recognise the operator, and as a project and receiver of requirements, there is an expectation that has been cascaded through to us so that we can then manage it. And the ongoing status of the franchisee. So as a project delivery office, we're working with the current franchisee within their SMS, ensuring that what we're doing actually will be consistent with their ability to accept it into service. But as they get refreshed, there may be new requirements associated with that contract procurement activity and the obligations they fit. But we capture that at a point in time, and that's what we're moving forward with.
Any more questions? As I walk over to you, I'm just going to mention also the projects module in the franchise agreement is quite clear in how we engage the franchisees for major projects as well as small projects.
Yeah. Hi, how do you go about quantifying safety and liability as requirements?
So how do you do that?
Quantifying it, putting a measurable,
Oh.
how do you measure that you've achieved it?
Okay, so anything that's got a safety function, the standards actually cover that, the Railway Centrelec standards, so 50128 and 129, defining safety integrity levels. So that's got a defined value associated with probability of the system not doing a particular function, and so you then use those limits and develop all your event trees, the failure rates associated with them to be able to demonstrate up that your performance actually is within the required band for that particular safety product. So from the highest integrity product, SIL 4, that has to achieve a value of obviously a very low 10 to the minus 7 or in that order of failures in service of operation. Whereas a lower integrity product like a train control system, as an example, wouldn't have to achieve that level of performance and that low number of potential failures.
Is that standard peculiar to the rail industry?
No, it's comparable to 61508. Yeah. Mm-hmm.
EN 50126 is rail specific.
Yes. Oh, so,
50129 is
Yep.
signaling system.
Yep.
rail.
Yeah, but the SIL levels are effectively the same across
Yes.
different industries. Yeah. Mhm.
Might cut us off there. Thank you again, Marc. It was a really great demonstration of really this is the biggest application of systems engineering I've seen in my career, and it's definitely a huge growth which you've demonstrated today. And just in that question time, it's amazing how you can delve back into the detail and up to governance. So I really thank you for sharing your time with us and sharing your work with us. And quick round of applause.
Thank you. Thanks, Eric.
And one
Turn that
last
off.
question. Oh yeah, turn that off. One last question.